Hi guys, welcome to another video. In this video we are talking about software architectural patterns. What is an architectural pattern? It's the first question. But before major software development starts, we have to choose a suitable architecture that will provide us with the desired functionality and quality attributes. Hence, we should understand different architectures before applying them to our design. And the definition to the architectural pattern, in this case, it is a general reusable solution to a commonly occurring problem in software architecture within a given context. Architectural patterns are similar to software design patterns, but have a bigger scope or a broader scope. And we start with the first architectural pattern. It's the layered pattern. This pattern can be used to structure programs that can be decomposed into groups of substacks, each of which it is at particular level of abstraction. Each layer provides services to the next higher layer. The most commonly found 4 layers of a general information system are as follows: the user interface layer or presentation layer, the application layer, that is also known as service layer, the domain layer or business logic layer, and the last one is the data access layer, also known as persistence layer. Normally we use this pattern or architectural pattern in the general desktop applications or in an e-commerce web applications. The second architectural pattern is the client-server pattern. This pattern consists of 2 parties, a server and a multiple clients. The server component will provide services to multiple client components, and the client requests services from the server, and the server provides relevant services to those clients. Therefore, furthermore, the server continues to listen to client requests. Some or the most common use for this architectural pattern is an online applications, for example an email or document sharing, for example the drive or whatever other like that. And we have in the tier pattern or tier architectural pattern the master-slave pattern. This pattern consists of 2 parties, like the client-server pattern, but in this case are the master and slaves. The master component distributes the work among identical slave components and computes a final result from the results which the slaves return. In this case, some example is in database replication. The master database is regarded as the authoritative source, and the slave database are synchronized to it. And normally these architectural patterns are applied to some distributed application or distributed infrastructure like the databases. The next one is the pipe filter pattern. This pattern can be used to structure systems which produce and process a stream of data. Each processing step is enclosed within a filter component. Data to be processed is passed through pipes. These pipes can be used for buffering or for synchronization purposes. Some examples are workflows of bioinformatics or compilers. The consecutive filters perform lexical analysis, parsing, and semantic analysis and code generation. And we have the broker pattern. It's the next architectural pattern. This pattern is used to structure distributed systems with decoupled components. These components can interact with each other by remote service invocations. A broker component is responsible for the coordination of communication among components. Servers publish their capabilities to a broker, and the clients request a service from the broker, and the broker then redirects the client to a suitable service from its registry. Some example is the message broker software like the Apache ActiveMQ. It's an example of this kind of architectural pattern. The next one is the peer-to-peer pattern. In this pattern, individual components are known as peers. Peers may function both as a client, requesting services from other peers, and as a server, providing services to other peers. A peer may act as a client or as a server or as both of them, and it can change its role dynamically with time. Some example of that kind of architectural pattern are the file sharing networks or multimedia protocols, for example the P2P TV or PDTV, and some file sharing networks are like everyone or every service that use the torrents, for example. The next one is the event bows pattern. This pattern primarily deals with events and has four major components: the event source, the event listener, the channel, and the event bows. Sources publish messages to particular channels on an event bows. Listeners subscribe to particular channels, and listeners are notified of messages that are published to a channel to which they have subscribed before. Some examples are the notification services and maybe an Android development that use this kind or whatever mobile development that use this kind of architectural pattern. The next one is the model view controller, that it's one of the, or it's the architectural pattern that we are focusing in this lesson. This pattern, also known as a MVC pattern, divides an interactive application in three parts. The first one is the model that contains the core functionality and data. The second one is the view that displays the information to the user. And the third one is the controller that handles the input from the user. This is done to separate internal representations of information from the waste information it's presented to and accepted from the user. It decouples component and allows efficient code reuse. Maybe the major applications for this kind of architectural pattern it's the World Wide Web applications, and they can use a lot of programming languages. For example, Django, Rails, React, Vue, Angular, Laravel, PHP, Java, C# or ASP.NET Core, for example, are many languages that support this kind of architectural pattern. And the next one is the Blackboard pattern. The Blackboard pattern, sorry. This pattern is useful for problems for which no deterministic solution strategies are known. The Blackboard pattern consists of three main components. The Blackboard, it's a structured global memory containing objects from the solution space. The second one is the knowledge source. It's specialized modules with their own representations. The third one is the control component that selects, configures, and executes modules. All the components have access to the Blackboard. Components may produce new data objects that are added to the Blackboard, and components look for particular kinds of data on the Blackboard and may find this by pattern matching with the existing knowledge source. Some examples that use this kind of pattern are the sonar signs interpretations, maybe the vehicle identification and tracking, and speech recognition. The last one is the interpreter pattern. This pattern is used for designing a component that interprets programs writing in a dedicated language. It mainly specifies how to evaluate lines of programs known as sentences or expressions written in a particular language. The basic idea is to have a class for each symbol of the language. Database query languages like SQL are some examples of this architectural pattern, and languages used to describe communication protocols are another example. And that are some of the most common architectural or software architectural patterns that we can use or we can know. And I consider that the MVC pattern or the model view controller is one of the most common in the development world or the web development applications, and we can know more of this particular pattern in this lesson. And that's it, guys. Thank you for watching this video, and remember, proudly UTR.